Hello and welcome to Mike Dolan Games. Today we're going to have another tutorial continuing our Make a Space game in Unity series, and also continuing our behavior tree AI portion of that series. And I apologize for my voice. I've got a little bit of a cold still, so I've been fighting it over the last week, so partly why I haven't been able to make an update until now. But I wanted to show you how to do some simple obstacle avoidance for our AI here. And it's a technique that shows up in a lot of game AI books and tutorials and blogs and things like that, and it works okay. I struggled with trying to get it to be kind of as perfect as I could make it in like a thick asteroid belt like this. Unfortunately, nothing is perfect, and you can see they do fly around the asteroids and things like that. Every now and then they take a turn too quickly, they get stuck, or they crash, or they explode. The current version of the obstacle avoidance, I think, gotten pretty close to not having too much of that, but it still does happen. So let's see what this guy does. So there's a guy that got stuck right there, but the other guys, that guy just threaded right through like 2 asteroids, and so not too bad. Anyway, looks pretty cool when it works, and I'm a big fan of A-star and nav meshes and things like that, and I have some ideas for how to set something like that up in a 3D environment like this, but it's a, a longer series, so I thought we would do this and then kind of see what other features we might want to add to our space shooter right now, and or some other space sim ideas. So, but we'll get some kind of interesting AI up first. So let's get started. Okay. So, all right. So make sure you open up your tutorial Unity project, and we're going to dive right into the code. So there's a couple things we're going to set up today. So if you've been following along, hopefully you have. This will be a little bit of a weird place to start. So go back to some of the beginning of at least the behavior tree tutorials to kind of get started. This is like number 4, I think, in the series, so it will be difficult to start here. But we have our behavior AI interface. We have an AI controller, which is basically like our kind of input system for AI ships. The ship controller, which is used by the player and the AI. And we haven't changed that in a while, and we're not going to. And then we have a couple of behavior scripts that we're going to modify. So one of the ones we're going to modify actually is the check arrival task, because in order to make our collision kind of a little bit smarter, we're going to do things a little differently with this. Okay, so I'm also going to kind of hack our turning to the target behavior and make a new behavior that we're going to replace it with. So, okay, so let's get started. So we're just going to do some quick setup work here. So in our behavior AI interface, or iBehavior, we are going to add a couple new methods here that we're going to have to implement in our AI controller. One of them is actually just called get avoiding flag, and then we're going to implement some ways to kind of set like a temporary target to help us navigate around our things without like kind of like thinking about turning away from something and then just immediately going back. That's one of the ways that we end up with collisions. So we're going to set a temporary target, and we'll just give it a vector 3 and position. And then we're also going to need a way to get our old because, like, say we're chasing the player, or we are going to a waypoint, we're going to need a way to return to the target that we were going to. That reminds me, I need to look at this because I think I may have set it up in my demo in a way that might lose when they're chasing a player. I'm not sure. Okay, so that's interesting. Gotta look at that. Okay, so I think these three things are what we're going to need. Yeah, let's start here. Okay, so these are the things we're going to need to implement. So save that. Go into your AI controller here. Hopefully yours looks a lot like mine. You'll see your interface is red now. If you like using shortcuts like I do, just hover over it, hopefully, or not. It's not working. Okay, well, just scroll down to the bottom, and we are going to add our new interface methods here. So we need our public bool, and we're going to call that get avoiding flag. So basically, if our avoidance starts to kick in, we're going to create a flag just called avoiding. And we need to define that as well. We initialize that above. So we're going to return that. So we'll store that up here. We'll just call it avoiding equals false. Okay, so when we start off, we're not going to avoid anything. All right, so the other ones we need are our public vector 3 set temp target, and this will take a vector position. All right, so this is where we figure out we're going to collide with something, so we find kind of a safe direction to go that's just a short distance away, and we set a target. This will help us kind of go around things. So, and this is going to return position. Okay, so we're going to check if avoiding, we're going to set avoiding to true here. Okay, and then, because if we call this, it means that we're setting a temporary target, it means we're avoiding something. So then we're going to set our temporary target to be equal to the position we pass in, which we'll get from our the avoidance behavior. Saved target position equals target. I guess it's my target position. Okay, so and this is where I'm thinking we might need to worry about if we're chasing someone too, because this won't save that, but I guess it will. It won't matter, because if we're not avoiding and we have a target set, then our other move to target behavior actually checks for that, right? So so that'll be okay. Yeah, okay. I feel like there's maybe a flaw in my code that I need to fix. Okay, so we'll have to pay attention to that. It seems to be working, but maybe that's where some of the crashing still happens. Okay, if they're chasing something, maybe the temporary target doesn't get set. All right, so if we have this, we actually need these two variables as well, initialized at the top here. And these need to be part of the class because they need to exist for multiple frames and things like that. So we can't just define them in that method. Okay, so this is a vector 3. Oops. And this one is vector 3. And we're just gonna what did I do? Okay. All right. So there you go. We have those. All right. So what was our last one that we needed? So now we need this one. And this doesn't take anything, but it returns save target position. Okay, so now we'll just return the one that we saved from before, because we're going to set our target position. Yep. Okay, so we also need to set avoiding false a temporary target to just like vector 0. My target position equals save target position, and then we're going to return my target position like that. Okay. All right, so yep. All right, so that does what we want. And so now we have kind of our basic groundwork set up for our obstacle avoidance. So is there anything else I need to set up? I don't think so. Yeah, okay. All right, so let's set up a quick version of our collision avoidance. And yeah, so that the idea that my the temporary position is not going to work probably when the AI is chasing something is starting to bother me. But this it works pretty well, so we'll go for it for now, and maybe I'll come up with a fix for it. Okay, so go into your behavior tree folder, create a new script, and you can do this through Unity as well. I think I showed you last time I have a shortcut there that I use. So we're basically just making a class. We're deriving it from the BT node. It's inheriting from the BT node there. So this is a new behavior tree node. And the new behavior tree node is going to be called like obstacle avoidance. I keep calling it collision avoidance, but technically collision avoidance is actually when you're trying to avoid other moving characters, whereas obstacle avoidance is where you're kind of trying to avoid walls and things that are blocking. So we'll call it obstacle avoidance to keep people from getting confused here. Okay, so yeah, so this is our constructor. Okay, so and we're also going to need some class variables for this BT node. So like all of our BT nodes, it seems like we have our iBehavior AI. We're going to need, I'm starting to question whether I really need to define these actually, but you know what, let's skip that for now. Okay, we're going to need our transform for our agent. This is our AI agent. We're going to need avoid distance. So this way we can kind of tweak how far away we want to track like an obstacle. And then we're going to use a layer mask. And I'm just going to call it avoid layer mask. And we're actually going to pass this in from the AI controller. I forgot we're going to have to add that. It's really easy to set up layer masks in the Unity editor, and it's kind of annoying to do in script because you have to use like bitwise modifiers. So I'm just going to do it in the editor. I'll show you how to do that. Okay, so we have our layer mask, we have our avoid distance, and we're going to need our turn event. So the way I have this set up right now is it's just going to replace our current turning behavior. And I think in the future we could probably set this up, or you can try to set it up yourself, to just like pass the new kind of turn to the turning behavior script. But essentially obstacle avoidance is all about turning as well, essentially. So yeah, it just made sense to make this kind of its own turning system. Okay. All right, so I think these are all the variables we need for now. So let's, so we're going to pass in our my AI. We're going to pass in the avoidance. And we are going to pass in our event. All right, so we're going to pass in those things, and then we are going to set them. So here, my AI equals, and then avoid distance equals. Okay. Sorry, I was just checking my mic. I realized I might have had it off. Okay, hopefully you can hear me all right. Avoid. So avoid distance. And the final thing is the turn event. We're going to pass that turn event in from our AI script. Okay. So we have those things, and now we can go down to our evaluate. So our evaluate always returns successes and failures and things like that. So right now we'll avoid this stuff. Okay, so I have kind of a streamlined way to do this. I've got a few kind of like external methods from evaluate that we'll use to create this, but let's start with the super kind of simple version of it. All right, so agent transform equals my AI.get agent transform. Okay, so we want to get like the most fresh version of our transform here, and then we are going to create an array of basically ray directions, because we're going to use ray casting. And the way this is going to work is we can store all of them in here, and then instead of having like a ton of repetitive scripts, we can just kind of like run through the array however we want. So to start off, we're going to need a vector of agent transform forward. Okay, so we're going to check to see ahead of us whether there's an obstacle. So in the simplest form, that's like the one thing we need to do to double check. We're going to add a few more checks after this, but we'll start with just this one. Okay, and then the other kind of the simplest kind of solution is to kind of look at 45 degrees to the left and 45 degrees to the right to see if it's open. And if it is, then you can turn to one of those directions. So we're going to use an array that does both a left 45 and a right 45. And the way to create that, and I just put this in parentheses, so agent transform dot forward plus agent transform dot right and then dot normalized. So by adding these two together, you get the 45 degree kind of ray between the two. So and we're going to do the same thing for the left side, I believe. Vector math is not my strong suit, but okay, so now we have kind of a 45 to the left, 45 to the right. Now you can apply this for 45 degrees up, 45 degrees down, and then you can also do like custom angles, and I'll show you how to do that in a little bit. Okay, so now we have what's in front of us, and then we can check our two sides to see if we can turn. All right, so I'm going to give you kind of these things, and then I'm going to show you kind of the rest of it. There's a lot of typing and kind of just repetitive things, so that's why I'm going to give you just a little bit here to handle. Okay, so now we're going to create a method called draw raise, and this is just going to be a helper method for us. Ray direction. Actually, I want to call this directions. Okay, so we're going to pass in our array here, and now we do not have a method, so we can generate it. Okay, where did it get generated? Did it get generated? Ah, here it is. Okay, so we pass in our array called draw raise. So basically all we're going to do here is go for each vector 3 direction in, and then we're going to loop through our array directions, and all we're going to do is debug dot draw array, and we have our agent transform dot position, so we're going to send it right out from the center of our ship, and then direction times, and then I don't know, I always think like a debug array should just go infinitely because it's an array, but it always seems to work better if you have kind of like a multiplier on the direction to make it kind of go a certain distance. So if you multiply the direction by your avoid distance, you'll get like a longer array. A lot of times it's like really short, so even though my expectation would be it would go on infinitely because it's array, but it doesn't seem to do that. So just multiply it by the avoidance distance, and then give it a color. So I just do color blue. And it might be helpful for you to have different colors here. The way I have it set up, you're going to have to do some logic inside the for each, I guess, to choose a different color for each one. But it's not a totally big deal, but it might be helpful if you're like trying to figure out which one of these is the which debug array is matching up with, you know, the vector 3 array here. So you could have different colors and sort of figure it out. Okay. Anyway, this is just going to allow our ship to draw debug arrays so you can see what's going on in the editor view. You won't actually see it in the game. Okay. Now we're going to get into the actual avoidance. Okay, so first thing you want to do is we're going to, actually, do I need to, yeah I do, okay. We have to define a raycast hit. Alright, this is going to be the object that comes out of the raycast. And then if physics, so this uses Unity's physics raycast agent position. Okay, you're always coming from the position of the object. And also, if it comes from the center of an object, usually the raycast doesn't intersect, cause like a false intersection with the actual object that's shooting it out, so you don't have to worry about it. So make sure you're generating your raycast from within whatever object you're using, so you don't intersect with yourself. Okay. Okay, so and that gets more complex if you have like multiple colliders on your ship. Okay, so now this one we're going to do manually raycast. What do I call it? What is it showing up? Oh, it's just ray directions. Okay, so ray direction, and our first ray direction 0, is our forward, and that's what we're testing here. So and we want to send out that. How far do we want to go? That's this one, distance. All right, so where do we start? What's the direction? What are we going to drop out of the raycast? And then how far do we want the raycast to go? Avoidance distance. And then what do we want to collide with? Is the layer mask, and we have that, right? Oh, we didn't define it. Okay. So we want to add this in. Okay, so now we have this layer mask here. Still being weird. Ah, I put a parentheses here. Okay. Avoid distance. Avoid layer mask. Okay, so that will tell what we want to collide with our raycasts. Okay. And I spelled this wrong. It's just avoid distance. Okay. Okay, so within this if statement, we are going to say, okay, so we hit something, because if this comes back as true, that means we hit something. Okay, so that means we need to check to see if there is a way around whatever it is we hit. And you can do all sorts of stuff with the hit object. You could like figure out what it was you hit, things like that. But we're just going to look at our two side-to-side directions and see if we can turn. So I don't know if this is great for a variable, but I'm going to call it good turn, and we're going to create another method called check turn. And again, I just created these methods because this obstacle avoidance has like a bunch of raycasts, so it was a lot of the same code, so it's easier just to kind of have it in a method and then not to repeat yourself over and over and over and over and over again. There's still a little bit of that in here, but this is way better than what it looked like before. So, okay, so now we're going to define this, but this is basically going to shoot out another raycast. It's going to look like this. And if we don't hit anything, so if it returns true, then we will return a success, and that means that we don't have anything. Right, yeah. Yeah, we're gonna, let's see here. Yeah, we're gonna return a success. Okay, and so inside this turn, we're gonna do a bunch of stuff. Okay, yeah, and then if it does not return success, we're gonna keep going through our list, and this can get bigger. And then after that, I actually just keep returning success for this. I guess the reason is I don't want like the movement to fail. So, and this would result in crashing and stuff like that. But it's kind of what we're up against. So, but anyway, okay, and we're gonna put some more code in here. But let's do this first. Generate. Okay, so in our check turn, we're going to do something very simple. We'll call this redirection. Okay, so basically for this, all right, and we have to define hit again. Okay, so we're taking in a direction, array direction that we want to raycast out to, and then we're going to do an if statement. But this time, it's very important that you put the exclamation here. It means that if we don't hit anything, that's a good thing for this because we want to see if we can turn. Okay, so all right, so we're going to cast out from our position the ray direction. We're going to return a hit. We're going to do it for the avoidance distance and the layer mask just like before. And then the other thing that's important here is this little piece of information. So we're going to multiply the ray direction. Instead of by the full avoidance distance, we're going to divide it by 4. So we're going to get like a quarter of the avoidance distance, so it's going to be a shorter ray. And what that does is it means that we're not checking all the way far ahead because there might be some giant wall or something. But if we can see an opening closer to us that we can turn to, then maybe we'll have a chance to avoid whatever is in front of us. If we use the full avoidance, we might keep hitting stuff and never turn. So a smaller avoidance distance here will allow us kind of to avoid things because we can make a tight turn. This might not work for bigger ships, I guess, but we can always add kind of some throttling to slow down based on possible collisions. Okay, so in here, so we're checking if we don't hit if we don't hit something with our raycast, that means we're going to turn. Okay, so and this is where kind of that important temporary stuff happens. So we're going to have something called new heading, and that's going to be our ray direction that we passed in. So if we're going that 45-degree angle, we're going to go there with our new heading. And so our we're going to get a new target, and that's going to be agent transform position plus new heading. And we're going to take that same calculation here. Now this, by adding that heading to your position, you're basically getting kind of the tip of the raycast, so the very end of the raycast. That's this location here, and that's where we're going to steer our ship towards it. Okay, so that's our new target. And then Now we get to use our new set temporary target to our new target. And then we're going to do our turn event. So if turn, I always do these checks in here. If the turn doesn't equal null, then turn event, new heading. So now this is where we use our new heading, because we always pass the heading vector into our turn event. So now we have a new target, and we're going to turn towards it. So there you go. And now what will be good about this is we have a temporary target, and even if we don't do, even if on the next round we don't see a collision, we'll continue on our avoidance trajectory because now we've kind of turned towards it. So maybe we won't actually be facing the problem, but we'll kind of get out of the way, and then we'll go back to our original heading. So that's what this is doing. And then, so once we do all that, we return true. Because we did it, we turned, okay? And then if not, return false. This turn didn't work, okay? Do the next one. All right, so this should be what we need for that. Okay, so finally, the last little bit we need to do is this. So we're checking to see if we collide with something. Oh, do I need another? Yeah. We're checking to see if we collide something. If we don't collide with something, what do? Okay, we want to do our turning, right? So in order to do that, we need to kind of take the same stuff that we had from before for turn to target, right? So we just say, yeah, I think all this would be fine. I'm not even going to worry about the if statement, actually. Okay. We don't really need to even define these variables, but that's okay. This one actually can just be agent transform. This will actually have to get that. Okay, so now we're just going to say get our target position, make our desired heading, whatever it is. I'm going to skip this logic here. All right, so now, and we'll just turn to that heading, return success. So even if we don't collide with anything, we're still going to return success because we were going to turn no matter what. Okay, one problem with this would be if we did collide with something, but we didn't get to do anything, then what do? Right? So we could either return success, or we can just have our ship just go towards whatever it's going towards. So I think I'm going to do that for now. Well, you know, the way that I had it originally, so I'll just do it, is return success. Now this would mean you don't do too much turning here. Okay, but we can't avoid it, so oops. All right, so the last thing I need to do is get this in here. Okay, so make sure you rename your file if you do it like I did. Okay, so that's kind of the basics for this really simplified version of the collision avoidance. We can try it out right now and see how it works, and then I can show you kind of how you can add on to it, and I'll show you my code, and you can kind of go from there instead of having to kind of retype a bunch of stuff. But let's see. I think the main thing I want to do is just, instead of this turn to target, I'm just going to do collision, obstacle avoidance. And let's see. So we need our AI, our avoid distance, which we don't have. Okay, let's add that into our inspector up here. Okay, so we'll make it public. Float avoid distance, and try 100 for now. Okay, so avoid comma. Okay, and then the turn event and the layer mask, and we're gonna have to define that one too. Okay, so let's do that. Oh, and end it with a comma. Okay, so we just got rid of our turning thing because this is going to handle our turning from now on, at least for this iteration. And we're going to add a public layer mask. I'll have to set that up in the inspector. Okay, so now we've added our avoidance here in our sequence, in our move sequence. So before we turn, we're going to check to see if we have to not hit something, and then we're going to avoid or not avoid and keep going. Okay, and it's always going to return success, so we'll always be able to move and shoot and things like that. Okay, yeah, okay, so let's just try it out. Okay, so we have our enemy ship and we have our good ship, and they now have an avoid distance here, and they also have a layer mask. So if you just put default for the layer mask, that's kind of like the default layer, and we can add back in, oh, is it really just one asteroid? Okay, wait. If you have asteroids that you created or just big cubes or something, you can throw those in. This might not be enough asteroids to be interesting, so I'm going to just make a bunch more. And then like how it's all, not sure what happened here, but it's alright. Do I have it on local? Is that why? Okay. Alright, let's see if that makes them avoid stuff. Okay, so now put in 1 billion trillion asteroids. We've already updated our AI script. We just have an avoidance layer of default and avoidance distance of 100, and everything in the asteroid field is on the default layer. So let's just see what happens. Okay, so they are very fast. They're trying to hurt me. Okay, let's just see what he does. They're very aggressive. So let's see. I feel like I need to make the asteroid field even bigger to kind of give it a good. Alright, let's just see if this helps them. So if I hide behind something, we should see them try to avoid me, try to get to me. I'd say he's avoiding asteroids, wouldn't you? I'm not. Okay, so he's currently they only can turn left and right, but they're actually doing a pretty good job avoiding the asteroids, which is pretty cool. And they're just fighting each other. So I'm going through a pretty dense asteroid field, right? So, okay, so let's go back to the script real quick, and I'll show you one more thing. Okay, so okay, so in your obstacle avoidance script, if you want to make this even more robust, but it will have more more raycasts, you can expand your array. Okay, so the first thing you might want to do is create a cone of vector 3s. So I have a way of doing that where I create kind of like a 10-degree angle from the front of the ship, and then I do it kind of all the way around, top, bottom, left, and right, and center. And if any of those hits, then we say we've hit an obstacle, and that way you can kind of cover like the width of your ship. So if your ship is 10 meters wide, then hopefully you're not going to like bump your wing on a asteroid or something like that. So that's why we would do that. We would create a cone, and then after that you can create a number of different turn vectors that might help you kind of navigate that turn. So 45-degree angles are great. You can make any angle you want. So I do 45 and then right angles. I don't think I see too many right angle turns, but you can do it. So I'll show you that real quick, and I'll also show you up and down. So I'm just going to copy and paste this. So underneath these, so I just pasted these in here. So basically we have so these are almost the exact same kind of 45-degree angles, but now they're up and down. Okay, and then down here we have our right and our left, because we have negatives, and we have our up and our down negatives. So if you don't subtract from forward, you get a full 90-degree turn. So we can pass these in now to our raycast loop to find a good turn, and it will determine whether we have enough stuff. So okay, so the other thing, yeah, and so down here right now we started at 1, which is this one, we're skipping forward. So that's something to keep in mind when you start adding the front cone. So the front cone is a little bit more complicated. So what I've done is I've created a script called like a helper utilities, and I'm starting to add different things into this. And so the one that I want to show you is, now I learned about this on the internet. I forget where, somewhere probably on like a Stack Overflow. I did not come up with this myself, so the kind of the cosine and the sine math are kind of ways to find the correct vector based on the angle that you're turning. So that's what this is doing. So okay, so let me explain. I'm creating a helper utilities class, and we're going to be able to call it from kind of all of our scripts. Okay, so I made this a static vector3, and it's called get direction from angle in degrees. And what you can do is you can pass in a angle that you want in degrees, so 30 degrees, 90 degrees, 45 degrees, whatever you want. Pass in your transform forward. So whatever object you are currently trying to figure out the angle from, pass that in, and then also pass in the rotation plane. So it's not necessarily the axis, it's like the plane itself that you're turning on. I got confused with this when I was doing it. Usually you pass in the rotation axis, so if you're turning right to left, you pass in the up-down axis, but actually if you're turning right to left, you want to pass in the transform right, okay? So something to keep in mind in here, it doesn't work the same way, okay? And so what this does is it gets the angle, and it takes your angle in degrees and it multiplies by this function, which turns degrees into radians. And using radians, we can actually do some vector math to get the direction vector that we want. So this A is now converted into a radian. And so we're taking the transform forward, multiplying by the cosine of the angle, and then we're adding in the rotation plane that we're turning on and multiplying that by the sine of the angle normalized. This gets you the direction that we want in the degrees that we want. Okay, so if you use this in your obstacle avoidance, you can actually create a bunch of other vectors to test. So one example is this one. So as long as you have the static on it, you can now do helper utilities and then get direction. And it should just pop up. And then we're going to pass in a 10 degrees, the agent transform forward and the agent transform right. So we want to do 10 degrees to the right. And then you can do the same thing again, helper utilities dot get direction from degrees, and you can do 10f and copy this stuff because it's monotonous to keep doing it. Okay, so we have it, and now instead of positive 10 degrees, you can do negative. Now we have left 10 degrees and right 10 degrees. Okay, and you can do this for up and down as well. And when you do that, you have your kind of collision cone. All right, so now this takes up your 0, 1, 2, 3, and 4 of the array, and then the other ones are your turns. So we're going to test all of these, right, in the first round, right here. And then the rest we're going to do 5, 6, 7, 8. So we're actually going to start here at 5. And you want to basically copy to here and then do a double line there like that, and you can paste in one more. Okay, so now you have your ray direction 0, ray direction 1, ray direction 2, ray direction 3, and ray direction 4. These are kind of the cone in front of your ship. If they hit anything, it means that your ship can't fit through wherever it's going, and we need to now go through our list of directions to choose. Okay, so this kind of makes a more robust obstacle avoidance algorithm here. Still, it's not perfect. I really think pathfinding is kind of the most perfect solution for this type of stuff, but we're going to have to come up with an interesting and dynamic way to generate that without crashing our computers. So in the future, I'm thinking job system and some sort of node-based A star. Okay, I think that's kind of the major part of this obstacle avoidance that I wanted to show you. So again, we're creating a helper utility. This is what it looks like. Get direction, angle, and degrees, and you can add all sorts of stuff to this that you might use all the time. I'm adding like lerping functions, and I'm going to add some of my intercepting vector math stuff, so like ships can intercept each other based on like how fast they're moving, things like that. So you can use a helper utility to do that. Okay, so we just added our new AI, and you'll see if I bump this up a little bit. Now you have kind of your porcupine AI here. And you'll see, if you look closely at these ships, they have this kind of cone in front of them here. And then out to the sides are all of their like choices that they might choose when they hit something. Okay. Currently, they're not raycasting anything other than the front here. These turn ones aren't ever raycast unless you're looping through to figure out what where you want to go. So right now, and you could even set this up if you really wanted to optimize. You could say, let's only do the first center one, but if you do that, then you might hit something on the edge and then catch your wing or something like that. So let's see. So again, the raycasting, it's not perfect, but they do a pretty good job flying through and not crashing into things. So that's pretty good. And I do have this set up, I think, to hurt the ships if they crash too many times. So they're doing a pretty good job avoiding that. There's one guy getting stuck on a thing. So if they get too close, they will bump in a little bit, but because of the temporary targeting, they do have a better time getting away from it. So hopefully you found this tutorial helpful. If you did, make sure you like and subscribe and share with folks on the internet. I'm trying to grow the channel, and hopefully sharing my ideas is interesting to folks out there that want to create games in Unity. And if you have any questions or comments, please send them my way on YouTube or on Twitter. And I'd love to hear from you. All right. Thanks a lot, and we'll just maximize this. Oh, the player already died. So hopefully that was helpful for you. All right. I think after this tutorial, we might start adding some additional features. I know I was thinking about adding in some like non-combat NPCs, like a transport vessel or something like that. But also I want to look into other cool features for space sim games. So we can talk about different kind of component systems for our ships. We can talk about like background economies and things like that. I also want to get into more location stuff. So I think it's time to maybe fly to another part of the galaxy or another part of the solar system. So that's another kind of big area for space games, and this game should be able to do that. So we'll get into that and maybe some floating point, floating origin techniques, things like that. All right, so I hope you enjoyed this, and I'll see you next time.